Okay, now let's go through question 2. It says figure 2.1 shows the wiring of a 3-pin main plug. Name the component placed in gap X. So can you see here, this is the live wire. So gap X here will most probably be a fuse. So explain the purpose of the component in part A1. So what's the purpose of it? So a fuse consists of a thin wire. Okay, when excessive current flows through it, comma, it will melt and blow, disconnecting the high voltage terminal. Sorry, let me erase this. High voltage terminal from the appliance. Okay, so I'm writing out the really full answer. And anyway, do take note when we talk about excessive current here, this excessive actually just means current that is above the fuse rating. So it really depends on what is the fuse rating over here. Okay. Now part B, it says a plug is attached to a small electric immersion heater. The heating element is enclosed inside a metal tube. The thermal energy is generated when electric current passes through the heating element. The immersion heater can be used to heat water in a metal cup, as shown in figure 2.2. Part 1 asks, explain why the metal tube of the immersion heater is connected to the earth pin, E of the plug. Okay, so why is it connected to the earth pin? So as the metal tube is a conductor, comma, in situation where the appliance becomes faulty, the earth wire will draw current away from the metal tube. So what does this do? It prevents the user from getting electric shock or getting electrocuted. Okay? Now part 2. The immersion heater is placed in a metal cup of cold water and switched on. Explain how the water on the top of the metal cup becomes warm. So this is a question on convection. Okay, so this is our heating, talking about warm, talking about the cold water. So water being a fluid, how does it get hot? So this whole idea here is just a standard answer for convection. So I'm just going to write it down. Water near the heater, okay, gets heated, expands, becomes less dense, and rises. The cooler water at the top, okay, is denser and it sinks. Okay, so this sets up, this process repeats, and sets up a convection current. Convection current. Okay, and sets up a convection current, causing the water to be heated up. to become warm, okay? To become warm. Okay, so that's for part 2. Now part 3. Suggest a change in the setup without changing the immersion heater to speed up the rate of heating. Now, if I can't change the immersion heater at all, right? So if I can't change any part of the immersion heater, the next thing is really to look at this cup over here. Okay, so a few things you can actually do because I think they didn't state the material of the cup. Okay, so maybe use a cup that is made of plastic. Okay, because this is a poor conductor of heat. The other one is use a lid on the cup. Okay, why use a lid? To really prevent heat escaping due to convection. Okay, now part C. The immersion heater is rated 0.50 kilowatts. It takes 1 minute to boil the water in the cup. During the day, 6 cups of water are boiled. Calculate the total cost of using the immersion heater on this day. So when we need to find the cost of the immersion heater, do take note you need to find energy multiplied by the rate to find the cost. Okay, and this energy needs to be in terms of kilowatt hour. So already the power given here is already in kilowatts. So this power in kilowatt. Sorry, let me rewrite this. This already power in kilowatt. Okay, so it takes 1 minute to boil. So this is the time, but this is in minutes. And during the day, 6 cups of water. So I need to multiply by 6 in terms of the energy required. So how to go about doing this? First, let's find the amount of energy. Okay, so I know power equals to energy over time. The power here is 0.50 equals to energy over time. Time is 1 minute multiplied by 6 because I boiled 6 cups of water. But do take note, this is in minutes. So I'll need to divide this by 60. Or I need to divide this by 60 so that I can get it in hours. So 0.50 multiplied by 6 divided by 1 times 6 divided by 60 is equals to the amount of energy required. So what you're going to get over here is energy equals to, let me press my calculator, 0.5 multiplied by 1 multiplied by 6 divided by 60. Okay, so what I'm going to get is 0.050 kilowatt hour. So calculate the cost. So the cost as mentioned is equals to the amount of energy multiplied by the rate. So the energy is 0.050 kilowatt. The rate is 25 cents. So I take this multiplied by 25. Okay, so 0.05 multiplied by 25. What I'm going to get is 1.25 cents. Okay, so I need to convert it to dollars. So this will be equivalent to 0.01, yep, 0.01 cents. Okay, so if I round off to at least two significant figures, so 0.013 cents. Wait, 0.013 dollars. Sorry. Thank you.